Welcome to the channel of Vedant classes. Today we will see the chapter 5, Periodic Classification of Elements. Introduction. There are 114 elements known at present and it is very difficult to study the properties of all these elements separately. Around the year 1800, only 30 elements were known. Scientists started looking for some pattern in their properties on the basis of which they could study the elements with ease. Therefore, the elements have been classified into groups based on similarities in their properties. Early attempts at the classification of elements. The earliest attempt to classify the elements resulted in grouping the elements as metals and non-metals. Later further classifications were tried out as knowledge of elements and their properties increased. John Wolfgang Dobrynier. In the year 1817, a German chemist, John Wolfgang Dobrynier, observed that certain elements had similar properties and that he could put them together in groups of 3 elements. These groups were called triads. Dobrynier's law of triads: when the 3 elements in a triad are written in the order of increasing atomic masses, the atomic mass of middle element was roughly the average of atomic masses of the other 2 elements. Dobrynier triads: lithium, sodium, potassium. The atomic mass of sodium is average of atomic mass of lithium and potassium. Calcium, strontium, barium. Atomic mass of strontium is average of calcium and barium. Chlorine, bromine and iodine. Atomic mass of bromine is average of atomic masses of chlorine and iodine. Limitations of Dobrynier's classification. It failed to arrange all the non-elements in the form of triads of elements having similar chemical properties. Dobrynier could identify only 3 triads from the elements known at that time. Hence, this system of classification was found to be useful. John Newland. In 1866, John Newland's own English scientist arranged then known elements in the order of increasing atomic masses. He started with hydrogen and ended at thorium. He found that every 8th element had similar properties of first, just like the notes of music octaves. Newland's laws of octaves: when elements are arranged in order of increasing atomic masses, the properties of every 8th element were similar to that of the first. Newland's octaves. Limitations of Newland's law. It was applicable only till calcium, that is, after calcium, every 8th element didn't possess the same properties of the first element. Newland assumed that only 56 elements existed, but later other elements came to place and didn't fit into this law. In order to fit elements into this table, he fit elements like column as fluorine, chlorine and bromine, which have different properties than these elements. Fe, which resembles the cobalt and nickel in properties, was kept far away from these elements. Dimitri Ivanich Mendeleev. In 1869, Mendeleev, a Russian scientist, arranged the known 63 elements on the basis of similarities in properties. Among similarities, he concentrated on the compounds formed with oxygen and hydrogen. He arranged the elements on similarities in formula of compound oxides and hydrides formed by these elements. His observations: most of the elements that got a place in his periodic table were arranged in order of increasing atomic masses. There occurs a periodic reoccurrence of elements with similar physical and chemical properties. Mendeleev's periodic law. Mendeleev formulated a periodic law that stated that the properties of elements are periodic functions of their atomic masses. Mendeleev's periodic table contains columns known as groups and horizontal rows called periods. Mendeleev's periodic table is shown here. Group 1, Group 2, Group 3, Group 4, Group 5, Group 6, Group 7 up to Group 8. Achievements of Mendeleev's periodic table. There were some cases where the elements slightly having higher atomic mass were placed before the elements having slightly lower atomic masses. But the sequence could be inverted so that elements with similar properties could be grouped together. Example, cobalt appeared before nickel. Mendeleev left some gaps for elements which were yet to be discovered at that time. Achievements of Mendeleev's periodic law. He named them by prefixing a Sanskrit numeral ika 1 to the name of preceding element in the same group. Example, scandium, gallium, germanium discovered later had properties similar to ika boron, ika aluminum and ika silicon. Noble gases like helium, neon and argon were discovered very late because they are very inert and present in extremely low concentrations in our atmosphere. When these gases were discovered, they could be placed in a new group without disturbing the existing order. Limitations of Mendeleev's classification. Mendeleev couldn't assign a correct position to hydrogen. He placed hydrogen with alkali metals and again with halogens. Like alkali metal, H combines with halogens, oxygen and sulfur to form compounds. Also like halogens, it also exists as a diatomic molecules and it combines with metals and nonmetals to form a covalent compounds. Isotopes of an element have similar chemical properties but different atomic masses. So according to increasing order of atomic masses, they should be placed in different groups, but as they show similar properties, they should be placed in same group. Hence, the positions of isotopes was not certain. Limitations of Mendeleev's classification. Wrong order of atomic masses of few elements. Mendeleev arranged the elements in order of increasing atomic masses, but at number of places in his table this order wasn't followed. Example, aluminium was placed before silicon. Irregular increase in atomic masses. In this table, atomic masses didn't increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements discovered between two elements. The modern periodic table. In 1913, Henry Moseley showed that atomic number of the elements is of more fundamental property than its atomic mass. Mendeleev's periodic table was modified and atomic number was adopted as the basic of modern periodic table. Modern periodic table law states that properties of elements are periodic functions of their atomic number. The prediction of properties of elements could be made with more precision when elements were arranged on the basis of increasing atomic number. The modern periodic table helps overcome the three limitations of Mendeleev's periodic table. Position of elements in the modern periodic table. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. The arrangement is based on their electronic configuration. There is an irregularity when it comes to the position of hydrogen. It can either be placed in group 1 since the electronic configuration of hydrogen is similar to alkali, or it can be placed in group 7 with halogens because it forms diatomic molecules. The atoms of different elements with same number of occupied cells are placed in same period. The position of an element in the periodic table tells us about its chemical reactivity. The valence electrons determine the kind and number of bonds formed by an element. Modern periodic table is shown here. Trains in the modern periodic table. Valency. It is determined by the number of valence electrons present in the outer shell if its atom. Variation of valency in a period. On moving from left to right in each short period, the valency of elements increases from 1 to 4 and decreases to 0. Variation of valency in group. Since the number of valence electrons of all elements in group is same, all elements in group have same valency. Atomic size. It refers to the radius of an atom. Variation in period. On moving left to right, the size of atom decreases. Variation in group. On going down, the size of atom increases. Metallic and non-metallic properties. In the modern periodic table, a zigzag line separates the metals from non-metals. Metalloids, the borderline elements like boron, silicon, germanium, asbestos, exhibit the properties of both metals and non-metals. Metals, they are found on the left side of the periodic table. Variation in a period. On moving left to right, the metallic character of elements decreases. Variation in a group. On moving down, the metallic character of element increases. Non-metals, they are found on the right side of periodic table. Variation in a period. On moving left to right, the non-metallic character increases. Variation in a group. On moving down, the non-metallic character of elements decreases. Oxides. Oxides of a metal are basic and non-metals are acidic in general. Variation in a period. On moving from left to right, the basic nature of oxide decreases, the acidic nature of oxides decreases. Variation in a group. On moving down, the basic nature of oxides increases and acidic nature of oxide decreases.